All right, we are on section 7-6 now, so tangent functions and transformations. The majority of the lesson will deal with transformations, but I just want to introduce a tangent function since the last video we showed a sine and cosine function. So a tangent function, if you were to use this table, because that will explain where the graph came from, I put in different values of x, and then I figure out the sine over cosine since that's a definition of tangent, and then I worked out with a calculator what those values were. So what you're going to notice when x is 0, so we're at the origin, tangent is also 0 because 0 over 1 is 0. And then we have these other values that I plotted, but what's more interesting is this value down here for pi over 2. When you get 1 over 0, which we know is undefined because you're not allowed to divide by 0, that is going to create an asymptote. So these dashed orange lines are asymptotes. Okay, and the graph does not look the same as like a sine and a cosine graph. It's much different, but I just wanted you to kind of see what it looks like. The period of a tangent function is pi, so unlike sine and cosine where the period is 2 pi, we have half the distance, so from here to here is pi, from here to here is pi, from here to here is pi, and again you could just do 5 pi over 2 minus 3 pi over 2, and that would give you pi. Your asymptotes again are pi over 2, 3 pi over 2, 5 pi over 2, and it continues over and over. And your zeros, where I've circled in pink, is where your graph equals 0. So just a couple things. So when sine over cosine, if that value is undefined, that is where your asymptotes are going to lie. And again, undefined means the zeros in the denominator like we showed up here. But if sine over cosine equals 0, which it does for these values, those are going to be where your graph touches the x-axis. All right, so for the parent functions, we're going to use HK shifts. So your functions look crazy and they look really long, but it's basically like we've done before where you just focus on the different pieces. So first, we're going to focus on the a value. I will just mention that there's a couple differences for tangent that don't apply to sine and cosine. So as we go through these, I'll make those distinctions. So A we know is the amplitude or the height. Okay, well, sine and cosine have height because the graphs are curves, but tangent does not. So tangent, we will not state the amplitude like a height. You instead will just talk about the stretch or compression that occurs, okay? So you'll just do stretch or compression. Okay, so you won't say A is equal to something because again, how can you talk about height here when the graph is not going a curve like the sine and cosine? So A is the amplitude. Sorry, that's a little crooked. My writing's crazy this morning. So if the absolute value of A is greater than 1, then that's vertical stretch. If the absolute value of A is between 0 and 1, vertical compression. And if your A is negative, it's reflection. So very similar to what we've done in the past with parabolas, with absolute value graphs. The number in front, if it is bigger than 1, it's stretch. If it's less than 1 or a fraction, it's compression. So same thing. And again, here for tangent, you will not state an amplitude, like you won't say A equals, let me show you down here. Like here, A is equal to 4/3. You would not say that for tangent. You would just say 4/3 is greater than 1, so this would have vertical stretch. All right, let's come back here. B is going to help determine the period. And we basically are going to use a formula. So let me get our B's. Here's all the B's. If, when we're talking about, again, for sine and cosine, it's going to be 2 pi over B. But when you're doing tangent, it's going to be pi over B. Okay, so a couple distinctions. A lot of the things are very similar, but there's just those couple of differences. And then if b is greater than 0, b is greater than 1, it's horizontal compression. And if b is between 0 and 1, it's horizontal stretch. Now this is one that is new for us. So again, the main difference between sine, cosine, and tangent is sine and cosine will use 2 pi over b because their period goes for a distance of 2 pi versus tangent, the period only goes for a distance of pi. And then we have h. Here's our h. H should look very familiar, and it's a minus h just like it always has been in all the rest of the problems we've done as well. H is the horizontal shift. But the word they like to use more, since we're talking about periods and phases, is they like to call it a phase shift. So phase shift, and I believe the directions on your homework will say phase shift. And it just moves left and right opposite. And then lastly, we have the K. And K does just like it did before. K is the vertical shift. And it moves up and down. So we're going to piece all these together and we'll go through. So you're not actually going to graph any of these. You're just going to identify features of them. So the first example we have is a cosine. So to find the amplitude, let me do this just to make it easier. So I've color coded everything. So I'm going to kind of circle everything. So here's your A value. And then here's B. And I'm just matching it with what we have up above. And then I know that in the parentheses by the X is my H, and by itself is my K. So amplitude is 4/3. So we'll say amplitude 4/3. And then you also want to speak to what that 4/3 does. So 4/3 is up here. It's greater than 1, so you'd say vertical stretch. So 4/3 vertical stretch. Please, some of you only put stretch or compression. Now we have vertically and horizontally, so you can put VS if you want. That would work if you want to put a VS by it. But make sure you put the vertical or horizontal. The phase, so for the phase, we basically, not the phase, for the period, it's cosine, so we're going to do 2 pi over b. Let me do that over here. So 2 pi over, and we have a 1/2. So whenever you're doing a number with a fraction, remember what that really is. It really is 2 pi times 2 over 1, because you flip the bottom, so that's going to give you 4 pi. So our period is 4 pi. And then you also need to give me horizontal stretch. And when you do this, you want to be looking at the B value. So my B was 1/2. So 1/2 is not greater than 1. 1/2 lies here between 0 and 1. Okay, so you're not using the 4 pi. You're using the original B, and B is 1/2. So you're going to put horizontal stretch. Again, if you want to abbreviate in HS on there, that would be fine. The phase shift, this is just your H. So it's a minus pi/3. So we know go the opposite. So we want to move a positive direction. So we're going to go right pi over 3. And this is exactly like we've done in the past with parabolas, absolute value graphs, anything that we've graphed. And then the vertical shift is a positive 2. So you would just say up 2. And that's how that goes. So I'm going to stop the video here and I'll pick up with the examples that we're going to do. We have 4 examples. If you want to start on those using the information, we're going to just continue like that.